Assalamualaikum and hi everyone. Let's continue topic 6 with 6.2 geometric series. Our learning outcome for today is to use the sum formula and we will go to the sum to infinity. Before we go deeper, let's go to the sum to infinity. The sum to infinity of the geometric series is the summation from the first term, second term, third term up to infinite term, and the formula is a over 1 minus r and is denoted by s infinity. The value of r must be in between -1 and 1 only. Example 20. The third term of a geometric series is 24 and the sixth term is 3. Find the first term, common ratio and the sum to infinity. In the question, we already given this information. The third term is 24. Therefore, T3 equal to 24. Take out the formula for Tn for geometric series. Tn is equal to ar to the power of n minus 1 and we get ar square equal to 24. Let this one become your first equation. And the equation also gives us the sixth term is 3, means that T6 equal to 3. Substitute into the formula of Tn and we get our second equation, which is ar to the power of 5 equal to 3. Solve these two equations. Let's say I choose equation 2 divided by equation 1. Therefore, on the left side, I have ar to the power of 3 divide with ar square. And the right side, I have 3 from the second equation divided by 24 from the first equation. So now we can cancel out a and what we left here is r to the power of 3 equal to 1 over 8 and cube root of 1 over 8 we get 1 over 2. Now we need to find the first term. Let's say I choose the first equation. So I start from ar square equal to 24. Substitute the value of r, which is 1 over 2 that we have before. And simplify, we get a equal to 96. Next, we need to find the sum to infinity. By using this formula that we have discussed before, just substitute a and r and calculate, we get s infinity equal to 192. Example 21. The sum of the first n term of a geometric sequence is given by Sn equal to 15 times 1 minus 3 to the power of negative n. First, determine the n term. We know that to get Tn, we can use the formula Sn minus Sn minus 1. Substitute the formula of Sn that we have. And for Sn minus 1, we just change n here with n minus 1. Next, for 3 to the power of a negative n plus 1, we can split using properties of indices and we get 3 to the power of a negative n times 3 here. Expand and simplify. So we have Tn is equal to 30 times 3 to the power of negative n. Next, find the common ratio. To get r is Tn over Tn minus 1. Substitute the formula of n term that we get before. For Tn minus 1, we just change n with n minus 1. And simplify, we get this one. Next, we can cancel out 30 And for denominator, we split by using properties of indices and simplify, we get r equal to 1 over 3. The third question is find the sum to infinity. First of all, we need to find a by substituting n equal to 1 into the formula of Sn that we are given before. So we have a equal to 10, substitute into the S infinity formula, and finally the answer is 15. Example 22. The second term of a geometric progression, GP, is -4 and the fifth term is 1 over 2. Find the sum of the first n terms Sn of the progression. Find the sum to infinity S infinity. Hence, determine the smallest value of n for which the difference between Sn and S infinity is less than 0.001. So in the question, we have T2 equal to -4 and T5 equal to 1 over 2. Just take out the formula of Tn and we get AR equal to -4. Assume that it is the first equation. Next, the fifth term is 1 over 2. Take out the formula and we get AR to the power of 4 is equal to 1 over 2. Assume this one as second equation. Solve these two equations. So I let equation 2 divide by equation 1. This is what we have here. Cancel out A and simplify R to the power of 4 over R. We get R to the power of 3. The right hand side, 1 over 2 divided by -4, we get -1 over 8. Cube root of -1 over 8, we get -1 over 2. So next, find the value of A by substituting the value of R into first or second equation. Let's say I choose the first equation and I get A equal to 8. So now, we can find the sum of the first n term by using A and R that we have. The formula of Sn is A times 1 minus R to the power of n over 1 minus R. Substitute A equal to 8 and R equal to -1 over 2. So this is the sum of the first n term. Next, we need to find the sum to infinity. The formula of S infinity is A over 1 minus R. Substitute all the values and we get S infinity equal to 16 over 3. Hence, determine the smallest value of n for which the difference between Sn and S infinity is less than 0.001. First of all, we let absolute value of Sn minus S infinity less than 0.001. It can be S infinity minus Sn, but make sure you put the modulus sign so that the value is positive. So substitute Sn and S infinity. Factor out 16 over 3. And this one, what we left here. 16 over 3, we move to the right side and we get 3 over 16000. So, negative, we split this one. -1 to the power of n times 1 over 2 to the power of n. By using the properties of indices, A times B to the power of n, we can change into A to the power of n times B to the power of n. So these values will be positive because of the modulus sign. To solve this problem, we log both sides and check the value of log 1 over 2, and we can see that its value is negative. So So to get the value of n, we move log 1 over 2 to the right side. But remember, this sign will change because of the negative value that we have before. So now we get n greater than 12.38, and remember, n is the number of term. It must be positive integer only. So we approximately get n equal to 13. We already finished subtopic 6.2. Hopefully all of you achieve these 3 learning outcomes. That's all. See you soon.